Hello and welcome back to another VMK in the game development series. In this VMK I'm going to introduce you to a scene graph. What we've done up till now is we've created a game engine that will actually put objects into a 3D scene by specifying their X, Y, and Z coordinates explicitly. So whenever we had our houses we had to specify where in 3D space each of these objects sit. Well, this is fine for static objects, but whenever you start getting more complex and you want to implement things like characters moving around or dynamic objects that certain things are associated with other things in the scene, the way we've implemented the game engine right now, it's not very well suited for that. So a scene graph will help us actually alleviate a lot of problems. Let me demonstrate what I'm talking about. Let's imagine we have a 3D world that's completely flat. So we have the X direction this way, and we have the Y direction this way. You'll have to excuse my writing here because I'm trying to draw here with the mouse, and that's not very good. So let's imagine we have a circular object here. Imagine that being a circle. And to place this object, we have to specify an X and a Y value in our world space. So we can go ahead and do that. Now let's say we had another object here. Let's say this is a square, and I wanted to put it over here. Again, I'd have to specify the X and Y value, always with respect to the world here. Now, where it gets interesting is, if I want to make this object move around in a circle, let's say in a perfect circle around the first object, as if it's orbiting or something like this, I would need to go and calculate the X and Y values for each of the coordinates here in the circle, so that I know how to move this guy appropriately. Well, again, that's doable, a little bit complex, but still doable very, very easily. Where it gets complicated is, let's say now I want to take this circular object in the middle here, and I want to be moving him with respect to time. So as I'm moving him, I also want to have this guy follow. So in other words, this guy is associated with the circular object. Well, now the path that this square object's going to take is going to be something crazy. It's going to be maybe like this, because as this object is moving, the square object has to follow along with it. So it's going to be some crazy path like that. Now, to get the equation for this curve, it's going to get very complicated all of a sudden, because it now relates to how this object is moving. To simplify all of this, we can use a scene graph. And with a scene graph, what you can do is you can say, okay, I want to have this object associated with this object. So anytime that this object moves, this object also will move. And I can then independently control how this object behaves with respect to this one. And this comes in handy whenever you're doing character animation. So you can imagine a character is comprised of a bunch of pieces. We have a torso, we have its legs, and its legs are also comprised of pieces. We have like the thighs, the knees, the shins, and the feet. So as we move the torso forward, we don't want to go and try to calculate where exactly the hips are supposed to be located, where the knees and so on are going to be. Instead, we want to say move character forward, and as a result, all the pieces of that character will move together with the character. And then we can independently animate each of the feet, the arms, the head, whatever, so that the character actually comes to life and he's looking around, he's bending, he's jumping, whatever. This is very easy to do with a scene graph, not so easy to do if you don't have a scene graph. So that's why we're going to implement the scene graph.
My apologies about the audio earlier. I just noticed that my microphone wasn't connected up properly, so the first part of this video may be a little bit quiet on the audio, but I hope you can still hear what I had to say. Okay, so let's continue on. Let's go into our code and take a look at where we left off. Last thing we did is we implemented the font engine so we can display text to the screen. Well, what we're going to have to do is we're going to have to modify our existing code here because the way that I've structured it was I created nodes for the lights and nodes for the textures. However, when I actually sat down and implemented the scene graph, I noticed that this structure here wasn't really optimal. So I went and sort of worked how the lights and the textures work so that they fit more nicely with the scene graph. So as a result, these no longer are separate nodes, instead they're just classes. So what we're going to do is we're going to go in here and rename these existing classes to be just light, light directional, light point, light spot, and texture. We're going to get rid of the node part. The other thing that I want to do is set everything up so that in the next video tutorial we can actually go and start implementing pieces for the scene graph. So to do that, what we're going to do in this video is let's go into our scene, and inside initialize, let's just take a look here what we have. We do have a grid that we created and some houses. And then on update, okay, on update we're not rendering anything, so let's just go in here and render the ground for now, and go under the HUD and get rid of the text that's displayed on the screen. We just want a very simple scene to start working with, just to do tests. Okay, that built. Okay, so now we have our ground back in place. Now the thing you'll notice is our existing objects that we have, our flat grid, our house, triangle, and vertices, they will no longer work directly with the scene graph. So what we're going to have to do is we're going to have to rewrite some of the code here for these objects. Now this is not really that big of a deal because the existing code that you have there, we can actually cut and paste into the new code that we'll be using. We will be modifying some of the structure of it, but you'll see that with the new layout for the scene graph, things will be much, much easier to use. Right now, it's not very nicely set up to handle transparencies, but once we implement things into the scene graph, then transparencies will be very easy to do. And actually rendering, what we have right now for rendering, where was it? Under update. Under rendering, you notice now what we have to do is we have to specify each object and tell that object to render itself. Well, once we have a scene graph, all we need to do is write one function call, render scene, and it's going to go and render everything inside that scene. So we're not going to have to worry about exactly how we manipulate the textures and do all that, because everything's going to be linked in together. So it'll be very, very easy to use. Okay, so let's go and rename our existing classes here. The easiest way that we can do this, I guess, would be to do a find and replace. So if you press Control F on the keyboard, you should get a find window like this. And we're going to do a find for node light. We're going to select match case here, and select current project down here. And under replace, we're going to just replace node light with light like this. So click replace all. You'll get a little warning message. Just say OK. And 102 occurrences were replaced. We also want to replace node texture with just texture. And again, warning message, no specified text is found. Okay, that's strange. Let me just go and take a look at that. Node texture. Go in here, Control F, current project, match case, node texture, and hit replace, replace with texture, replace all. And okay, that did replace them because now inside the texture here, 36 have been replaced. Okay, so that's good. I think we were just in some wrong setting there before. So save all that. The other thing we want to do is anywhere where we had our defines for all of our node objects, so light, light directional, light point, light spot, and texture. So open up all the .h files. At the very top, we had node written here in front of the class. So because we renamed it, let's just go and rename the defines as well, just to keep things clean. Here's node light. And down at the bottom, replace this as well. This is just a personal preference. I like to keep things clean so that in the future when we do expand, if if for whatever reason we decide we need something called node light directional, well, it would work for us because this one here has been renamed to the proper value. One more, and the spotlight. Okay. Now, because we've renamed all of our classes here, what I would like to do is now go and rename these files so that we don't have node inside the file name. The easiest way to do this is to go into our Solution Explorer and highlight everything that has node in front of it and just delete it. So go in here and double click by accident and delete all of these. So we removed them out of our scene library project, and we can go into Windows Explorer, also under scene library here, and just renamed everything that's located here. So what I'm doing is I'm just pressing F2 on the keyboard. That's a Windows shortcut to rename a file, and I'm just going and deleting all of the word node in front of all the files. Okay, once you do that, we can now go back into our project, select scene library, right click, go add existing item, and we now can go and add all those items we just renamed. So we get all of our lights and our 2 textures. Okay, let's go and build this, make sure our program still runs and we still have that plane on the screen. Okay, and we do. So we haven't destroyed anything, we just renamed all those classes. Okay, the last thing I would like to show you is how a scene graph actually works. Now, I have this program here called VRealm, and unfortunately this isn't a piece of software that you can go out and purchase. It comes packaged with another piece of software called MATLAB. And MATLAB is an engineering tool that I use at work. So VRealm is available to me because I use MATLAB at work. Now, you don't really need this, but I just wanted to demonstrate how a scene graph works so that you get a sort of a better understanding if you are not familiar with a scene graph. We're not going to implement exactly what I'm going to be showing you here, but it's going to work very similarly. So what I'm going to do is create a new world. And currently there's nothing inside the world. So we have one node here, and that's called new world. What I'm going to do is I'm going to create an object in this world, and I'm just going to make it a sphere here. So you see, as soon as I create this object, what we have is we have a transformation node, which is underneath the root, and the child of this transformation node contains a shape node. And the shape node contains 2 items. It has an appearance and it has a geometry. The geometry says that this object is a sphere, and by looking inside the sphere here, we can see that we have a radius value. So by adjusting the radius, we can adjust the radius of the sphere. Under appearance, we have a bunch of nodes underneath here, and you can see we have a material node, a texture node, and a texture transform node. So you can imagine if I were to associate a texture with this, then the properties would be stuck under here. I could manipulate the texture using this texture node transform, and underneath the material node I can go and manipulate the color of this sphere, for instance, like so. Okay, now that's how VRealm handles the material nodes and textures and so on. We're not going to handle them this way. We're going to do things a little bit differently, not exactly as I shown here, but the general concept is going to be the same. We're going to have a transform node, and underneath the transform node we're going to be allowed to put children, and one of the children we're going to allow are geometries. So under the geometry we're going to specify what exactly we're putting there, and then we're going to also have with the geometry, we're going to associate materials, textures, and texture transforms. So we can color the objects, we can put textures on them, and we can manipulate the textures as well. Okay, now let's create another, actually let me shrink this sphere a little bit. So we have a small purple sphere here. And I'm going to create another object. But what I'm going to do is I'm going to create the second object nested with the first object. So I'm going to select children here, and we're just going to go and create this gray sphere. Now notice we have a transform node, that has a shape node underneath it and a second transform node. And this second transform node also has a shape node with some geometry in it. Well, now look what I can do. I can go and move this object so we can see our purple sphere underneath, and we have our two objects. Well, now here's where it gets interesting. This is where the power of the scene graph comes in. If I go into the root transform node, so the transform node that has everything nested underneath it, if I change the translation value here, what I'm going to be doing is changing the value of everything underneath it. So if I go and change the y value, for instance, notice that by changing one value here, I'm actually updating both objects. And if I had more objects nested underneath here, all of them would also move. Now, imagine the example that I showed you earlier with the orbiting square. Well, here, let's say that our purple ball here is some small planet, and we have some gray planet here that's huge. Well, what we can do is go underneath the root transform node here and select rotation. If we rotate about the z-axis, notice that the big sphere is rotating about that small one. So if we go and translate the small sphere up and down, well, the big sphere is moving with the small one. And we can also move it in the x direction as well. Notice that it also moves. In our game engine, what we're going to do is open up the ability to update x, y, and z for any transform node, as well as open up the rotation for any transform node. So you can go and update the position as well as the rotation all at the same time, and you can imagine we can have this object rotating while this object is moving at the same time. Now notice what happens here. If we go and select a transformation node down here and select the rotation, rotation, notice what happens. We're only rotating this object here. We're not rotating this one. This one is not moving with respect to the gray one. And I can demonstrate it a little bit better if we go and use instead of a sphere, let's go use a box. Because a box has nice square corners on them, so they're much easier to visualize what's going on. I'm just going to go and under the geometry here, delete the sphere and paste in a box. And I'm going to just delete that temporary box I created. So, okay, under rotation here, we can go and rotate the box, and notice that the box itself is rotating, but the purple sphere isn't rotating around my box. If I use this rotation up higher up, then as I rotate that, the box itself is rotating around the sphere. So it all depends on how this structure is organized. Depending on what's underneath what, then this rotation only affects everything underneath it. This rotation here does not affect objects that are above inside this tree. It only affects objects that are below. So again, if I go into the root and I, for instance, create a cone, now notice, I'll put this cone underneath this original transformation. Notice that I have one transformation here that has our purple sphere and our square box. And then we have a transformation down here. Well, these two transformations are not linked together. So when I go and translate this object up and down, the cone doesn't move because it's not nested underneath. Whereas if I go and select this translation, then I can move the cone independently of these two objects. So again, it's just how you organize everything inside the scene. So by creating this structure, you can then associate objects with one another. You can give them color, you can give them transparencies, you can give them textures, whatever you want, and everything is handled for you automatically. This is what we're going to be implementing in our game engine so that we can animate our characters, we can create different objects that are associated with other objects like planets spinning around each other. You can imagine cars, for instance. If you have a car object in your scene, what you can have is you can have a cylinder for, actually let me try to demonstrate this. We can create a, actually let's just delete everything out of the scene, start fresh. I'm going to create a very, very, very crude car here. Here's a one wheel, and I'll just copy this, and oh, why did I create a cone there? I'll create another wheel. This is going to be like a Fred Flintstone kind of car. So we have 2 wheels, and we have a box here that I'm just going to quickly scale, and we're going to call this the actual part where you're going to sit inside. So there's our car. Well, originally in our current game engine, what we need to do is we need to go, and if we want to move this entire object, we would need to say, okay, I need to take this wheel and translate it. So I would go, okay, I want to translate it so far ahead. Oh, now I got to go into this object here, and I want to translate it in the X direction. Oh, well, this wheel now here isn't moving, so let's go in here and translate that guy forward, and so on. Well, that's pretty complex. That's a lot of work that we have to think about what's associated with what. The beauty of a scene graph is, let's create a transform node, and then let's put all of these objects inside the transform node, like this. By doing all of that, now you notice that I have one transform node with these 3 objects nested together. Now if I want to move all 3 objects together, I just use this rooted transform node here. I can go into the translation, select X, and now notice everything is moving together. So everything gets grouped together, and you can move things much, much easier. We can also now rotate, whereas before, rotating would have been very difficult, but now we can say, oh, I want to be rotating. Now notice where we're rotating about. We're rotating about the center of this transformation node here. So if you want to know where the center is, you can put a reference point, or you can just play around with the center parameter. So by moving the center here, I'm changing where the pivot point is of our rotation. And we're going to go and implement all of this stuff. So now notice the rotation is somewhere around here rather than back at the other wheel. We're going to implement all of this in our own game engine, and it'll be much, much easier to handle all of the sort of dynamics that have to happen in a game engine. So hope you come back for the next video where we'll actually start implementing this stuff. If you're finding my video tutorials helpful and you'd like to continue seeing more videos come your way, please support my website by clicking on the PayPal icon down here to donate some money, or by clicking on any of the Google ads found on the side of the screen.